A second thing is pick the model. Okay. In machine learning, we have tons of model, right? Everybody will tell you you can use k nearest neighbor, you can use decision trees, you should use regression this, regression that. But I'm going to give you something very simple to follow. We can use it to split most of the machine learning models into two types. Number one is supervised. If you Google it later, right? All right, not now. Right? If you Google it later, that means when you're doing your revision, you can always Google for supervised machine learning models. Or when you read some articles, they will talk about supervised machine learning models. And the other one is called unsupervised. Supervised machine learning means that the process is under supervision, meaning you are actually providing the right values for your training data. So, for example, if you detect a face, right? Okay, you put my face into the data set and you label it as Dr. Lau. What the machine needs to do is to look at my photos and then to remember that, okay, somebody who looks like this with eyes like this, the distance like this, yada yada yada, is called Dr. Lau. Okay, and under supervised methods, we have two types of tasks. The very first type is prediction. So we use prediction class to help us to predict a label, an outcome. So for example, we give the machine learning models all the temperatures, wind speed, humidity data from the past 10, 20 years from Burel meteorology, meaning that we want to use the weather information to help us to make some forecasts, right? To make some prediction. So the prediction outcome will be whether it is something that is the weather is going to be windy, the weather going to be sunny, the weather going to be raining. Okay, so that is a prediction. And also you can let's go back to the telco example, right? You can give them the machine learning model a set of data that consists of how long this person has been with us, how many minutes he talk every month, how many gig of data that he used. And based on this information, you are able to predict for the past 3 months how this person has been behave and his usage pattern, and to guess whether this person will churn or will leave the telco providers or not. So under prediction, we have these methods called classification. Right, this chart will help you to determine what are the right models you need to use when it comes to different type of data. So classification, as the name tell you, you need to put things into their respective classes. Like for example, we take photos of human and we take photos of cats and dogs. We mix them together. The learning model needs to be able to accurately help us to differentiate what is which picture is a dog, which picture is a human. Okay, so that is classification. But classification only works for category variables, meaning that anything that has a categories. If you have something that's not categories, meaning that you have something that is numerical, all right, 1, 2, 3, 4, 5, your body weight, your what else? Your body height, your income level. Those are the things that are values, and we want to use it to predict our future value. So, in order to predict future values, this task is called forecasting. Right? A lot of people out there trying to build a finance model to predict the share price of a particular share tomorrow or next minute, right? That's what they call forecasting. Okay. And in order to perform forecasting, whether you want to forecast your sales or you want to forecast the demands of or supply of something, right? We can use this method called regressions, or to be exact, linear regressions. Okay. Now the opposite of a supervised method, of course, is an unsupervised method. The unsupervised method works when you don't have training data, right? Meaning, for prediction and forecasting, we already have some sort of historical data. For example, you can gather 100 images of a Malaysians so that we are able to tell the difference between a Malaysian and a Caucasian. You can also take photos of let's say you take photos of 1000 oranges and then you mark those oranges with problem, right? And then we are able to train the machine to detect which oranges has problem. Is it underweight? Is it black dots on the skin, for example, right? So those are supervised model. But unsupervised model is for us to use when we don't have access to that sort of things. You just get a lot of data points, and the most common one is the one that you've seen in the sensors, right? So you go to uh, like any of the IoT sensors, you go to government websites or you go to air quality monitoring websites. They're collecting a lot of informations about air quality, air pollution reading, but they are not doing anything to it, right? Those data are just sitting there. So we can use it for grouping, meaning we are able to group similar items together. So for example, people who always open their email between 9 to 11, we can group them together. And people who always sleep for less than 4 hours a day, like myself and Ruben, you can group them together. And by grouping these people together, you are able to perform what we call clustering. This is the technique that we use, right? K-means clustering. So by grouping these people into clusters, you probably know that, all right, somebody who opens their email from 9 to 11, usually they're working mom, right? Or they're full-time mother even. That means daytime they're very busy. They don't have time to open email. Only 9 to 11 o'clock before they sleep. But after their kids have slept, then they have time to read emails. That could be one of them. And if you look at somebody who always sleep for less than 4 hours, like myself and Rubens, these are the people probably they are in the tech industry, or like us, yeah, we are geeky because we just stay up till late night and we don't wake up too early on that sort of things. So that's what we call clustering. Okay, clustering basically to help us to group similar items together so that we can do some treatment to them. For example, after knowing who are the full-time mother and who are the techies, you can sell latest iPhones to the techies, or sell the latest napkins or diapers to the working mother. All right, so you understand when is it used. And last but not least, we have compressing. So compressing is a way for us to use unsupervised method to do reduction. For example, you have a lot of articles, right? You have 10,000 articles or legal documents that you have collected over the time regarding some topics, but you can't just do all of them together at one time. So you need to compress them into smaller space, reduce some of the keywords that are irrelevant, so that you are able to reduce them into less computational intensive information. Let's say if the article have 10,000 words, you should be able to reduce it to, let's say, 5,000 using some sort of compressions and reduction technique as well. Okay. So let's talk about forecastings and predict, right? Since tonight we're going to talk more about machine learning, so I'm more focusing on how the machine can learn. This unsupervised method is a little bit dry, like k-means. Broadly speaking, we have two major tasks, like I mentioned. One is to forecast, the other one is to predict. The one on the left looks a bit like Raja Bomo. So for forecasting, what we are trying to do here is we're going to predict the future value. So a very, very simplistic ways of representing values prediction, right, is actually a typical line plot. So for layman, you can remember the x-axis and y-axis just like input and output. So on the x-axis, we're going to it represents our independence variable. This is a simplified version, right? So we have only two variables, but in real world we have multiple variables, sometimes 50, sometimes more than hundreds. And the y-axis here is actually our dependent variable. So this is our output, or what they call the target variable. So long story short, given x number of x and then y number of y, we're able to plot it out and draw a line, and that line, that red color line, is your model. So after giving input and output, we're able to build the model by drawing a red color line, and this is what we call the predicted values. And all the other blue colors dots, we are calling it the observed values, meaning that we're using the observed values to help us to build the models. And after we have built the model, we can use it to predict our values. Okay, so that is number one, linear regressions. Number two, classification. Now, different from forecasting where we want to predict the estimate and value, right? Classification is actually for us to predict an outcome. So this is an example of logistic regressions. In statistic, right, the logistic model is used to model the probability of a certain class or event, such as if you look at this chart, right, the logistic regressions always have a value of 0 and 1. So if if the uh, if you look at the left hand side when it started, right, it started from 0, and after if it reaches a certain point, then the probability become 1. So we use this to model events like something that has a pass fail, right? Will you pass your exam, will you fail your exam, or win or lose, whether this team will win or lose the competitions, and then healthy and sick or dead or alive. Same thing, right? The x-axis is our input or independent variables. Y-axis will be our dependent variable, which is also our output. So how do you pick a model, right? It's actually very simple. You just need to remember that you just need to remember, if you have something that you want to predict the value, you can always go for forecasting using regressions. If you have something that is categorical, meaning that you don't have a numerical value, but you have a class or label. You have something that is true, false, yes, no, A, B, C, D, E, different types of movies, different types of genders, different type of characteristics, and then you can use classification. All right. So for unsupervised, very simple. Whenever you don't have a training data, meaning that you don't know, you have a set of data, but you don't know what sort of data is that for, you can choose to use unsupervised method. And under unsupervised method, you have two. You either use it to perform grouping, and grouping helps you to identify the relationship between all the data points, or you can do compressing by doing reduction so that you are able to find associations of their relationships among different data points. Okay. Now the one that I'm just show you is just a rough guide to get you started, right? Later on when you get the slides, you can look out for this sort of others machine learning models. We have on-zone methods, we have time series analysis, mainly for time series data like sales data, stock price data, random forest, nearest neighbors, to help you to perform classifications. And then k-means clustering is for you to perform unsupervised learning. And of course, you can build your own artificial neural network as well. And given that things like deep learning has become so easy nowadays. But no matter what you choose, right? Some advice I will give you is that high quality data always beats fancy model. Now, no offense, but if you have picked up Keras and you have picked up TensorFlow, make sure that you really understand what is that for. Okay, otherwise, in most cases, even like us data scientists, I don't use Keras in my day-to-day job. I only use deep learning when my linear models, by my decision tree models, my basic levels machine learning models are not working so well. It does not give me the accuracy that I want. That I will probably try to use deep learning or artificial neural network that helps me to address the issue. Otherwise, always start with simple models, because high quality data always beats fancy model. I'd rather you spend more time cleaning your data, because it's garbage in, garbage out. Find a good amount of data, find the representing data is even more important than finding a good models, right? A lot of models are based on assumption, based on generalization. So the same joke that I've said many times is, if myself, Jack Ma, and Bill Gates walk together into a room, right, the average wealth or average money that everybody has in the room has no meaning at all. Basically, my wealth and my valuation is brought up because of Jack Ma and Bill Gates. But am I that rich at like their level? Obviously not, right? So make sure that you always get good enough or good data that is very representative.